everybody. My name is Stephen Vasey. I am professor of sociology and political science at Duke University. And I'm also the director of Code Horizons, a part of Statistical Horizons. And we're bringing you this video to help you get started in R, so that if you're taking one of our R courses, but you're basically brand new to R, you can feel comfortable taking the course without getting too overwhelmed by new information at the beginning. So I'm going to walk you through a few steps here about getting started with R and making sure that you understand the basics of what's going on. So as we get started, there are a couple of things you're going to want to do. Let me share my screen. We're going to begin with so we're going to begin here with downloading and installing R and RStudio. So R we can find here at cran.rstudio.com. This is a great place for us to download R, and so we can download the version that we need. So I'm on Windows, for example, so I would download it from here. I would download R from here, and so I would download base R. It says this is what you want to install R for the first time, which is what I would be doing if this were brand new to me. So that would be step one, to install this. Now it's already installed on my machine, so I'm not going to do this. But this is it's going to look exactly like installing any other piece of software. Now, if you are on Mac, if you go here, you're going to see that the page is a little bit more complicated. What you want to do is pay attention to whether you are using an older Intel based chip in your Mac, or whether you are using one of the newer M1 chips. And so you can see here that this is for this first one here is for the Intel 64 build right here, and this one here is for the ARM64, the M1 chip build. So that's the first thing you want to do. So you want to download and install that like any program. So go ahead and take a minute and pause the video and make sure you've got that downloaded and installed. Okay. Once you've got that installed, we can think about R, which you just installed, as the engine of R. So this is the thing we're not going to look at a whole lot. We're going to instead use what's called an integrated development environment, or RStudio, to engage with R and ask R to do things for us and report the results. So we're going to download RStudio here at this link, rstudio.com. We're going to scroll down to here, download the free desktop IDE. And so here we are, RStudio. Everybody hopefully can see where we are. And we're going to look here, and we're going to just want the RStudio desktop, which is free. We will download that like any other piece of software. We will download that and install it as well. So go ahead and take a moment to install that. Pause the video, and then we will come back and talk about what to do once you've done those two things. Okay, once you have downloaded and installed R and RStudio, you're going to have, wherever you get your programs, you're going to get access to these programs. And so I put RStudio down here on the taskbar. I use it quite a lot. So I have RStudio on my taskbar. You can go ahead and click on that, and it's going to start up. And you will see that this is what my RStudio looks like. When you open yours, it might look a little bit different. And I'm going to show you the reason that is because you can customize the way your RStudio looks to your liking. So I will show you how to go about and do that. So the first thing we want to do is, RStudio does come with some settings that are a little bit suboptimal in my view. And so we're going to go up to here to Tools, and we're going to select Global Options, and we're just going to make sure a few things are in place here. So we're going to go to Global Options. You're going to see there are a lot of different options here. We're not going to get fixated on too many of these, although obviously they all do something. But what we're going to start with is just appearance. Well, actually, we'll start in the General tab, and then we'll do appearance in a second. So we'll start with the General tab, and you can see here that this is what I want you to have unchecked when we start. I want you to your work, these options to look like this essentially. The key area where I want you to look is from here down, basically from restore most recently open project at startup. You want to make sure that's unchecked. Restore previously open source documents at startup. You want that unchecked. Restore R data into workspace at startup. You want that unchecked. Save workspace to R data on exit. You want that to be set to never. And then we don't want to save the history. And yeah, we don't. So we want to leave these unchecked as well. Now these are, these are optional in the sense that, if you want to send, updates, be notified of updates to RStudio or send crash reports, that's fine. Of course, your paths up here to your to which version of R you have, those should be set automatically. That's not going to be different. We're not going to change those right now. But otherwise, what's going to happen is your computer is going to get sort of clogged with a bunch of stuff that it probably doesn't need in terms of your previous R output. So we're going to go ahead and just make sure that these 1, 2, 3, 4, 5, 6 lines look just like this. So take a moment and do that, and then we will move on. Okay. So the next thing we're going to look at here is the appearance. And so one of the things you can do is make things a little bit bigger, a little bit smaller. I'm going to just increase the size of my font here just to make it a little bit easier for you to see, or zoom a little bit, I should say, to make this a little bit easier for you to see. Yeah. Okay, and then you can change the font, to different things. You can change the font to whatever you want, whatever's installed on your machine. So I am going to stick with Lucida Console here, and it's looks a little thick on 110, so I might just go back to 100. It's a good size font, so hopefully everybody can see it well. So we're going to go here. We're going to go back to I keep having to go back here because when I apply it, it turns off here. But so we'll go back to appearance, and you can also change the color. I'm using this iPlastic editor theme because I like it. I like a little bit of a lighter theme. I go back and forth. I like a little bit of a lighter theme, but not sort of bright white. The default is, I believe, yeah, TextMate here. If I apply that, you can see it's, it's pretty bright. That's, I think, what yours will come with. And so I like this one because it's still, relatively easy to read for people on the screen. But you go ahead and fool around with these and see which ones you like. You can spend a kind of ridiculous amount of time. Trust me, working on this and trying to make things look the way that you want. So take a minute, pause the video, take a minute and see and get things sort of, don't spend too much time, but looking the way that you'd like them to be. Okay, so the next thing we're going to look at is your pane layout. And your pane layout may be slightly different from mine, but there are a few different things we're going to use. We're going to use the source and the console. So source is, let me show you what that looks like. We're going to, you can't see the source yet, you can only see the console. And the reason for that is because I haven't opened a source document yet. And a source document, it's very simple. A source document would just be an R script. So we're going to open an R script here like this. And all this is, we're going to do a lot more with this in a minute, but all this is a text file that we're going to put some R commands in, and we'll get some results out. And so this is the source file. If you're used to Stata or something, this would be a do file. This is essentially your script file. So this would be your source file here. So if we go back to global options and pane layout, you can see that we can put these things where we want them. So I generally have the source in the top left. I have the console in the bottom right. This is where you can type things interactively. And you'll also see the results of the things that you run up here. And then we have two other ones. We have the one, well, I mean, the fact is you can see all these checkboxes. You can organize these the way that you want. The way I have mine organized is that I do a lot with plots and I do a lot with the viewer. And so I have those in one spot up in the top left. And then I kind of put all the other stuff that I use a little bit less often in the bottom right. And so you can see I have this here. Now the defaults are going to work fine for you. There's no reason not to use the defaults. But if you want to move things around a little bit just to get the hang of it, you're welcome to do that. So I can switch the source in the console, or it will automatically switch them. So I'm just going to leave it the way that it is. This is how I like it. So I'm just going to leave that the way that it is. And then we will take a look at what these different things do. So if you need to, pause the video, fool around with these things a little bit. But again, the defaults are gonna work just fine for you in 99% of cases. Okay. All right. So here we are. I want to take a minute and just show you the console, because the console is where we're going to get the most basic sort of introduction to what R is like. So R is a programming language that's oriented towards statistics. And so we're going to be able to ask R to do things, and then it's going to do things. And so we can do things like this. We can do print hello world, something like this, and then we'll print hello world. See that little one just means that's the line of output that's there. You can use R like a calculator. You can try 2 + 2, and it will give you the answer, which is 4. You could say, what is 3 to the 3rd power? 27. So you can use R as a calculator. I often do use R as a calculator, in fact. So we can go ahead and do that. Now, one of the things that's interesting about R, especially if you're coming from a different language, if you're coming from something like Stata or maybe SPSS, is that R is what's called an object-oriented language. And so that means that rather than having just one data frame or one data set in memory, R can hold a variety of objects, and these objects can be of different types. So that's one thing that takes a minute to get used to. So right now you can see here there's an environment tab. It might be in a slightly different spot on your screen, but you can take a second and find that environment tab. One of the things you can see here is this says environment is empty. And that's because I haven't saved any objects to the global environment. But let's say I want to do that. Let's say I want to create an object called X, and I want it to just be, I don't know, the number 5. You can do the number 5 like this, and now what you have is there's an object called X, and what it stands for is the number 5. So I could do X + 1 is going to be 6. X times 2 is going to be 10, etc. So I can arbitrarily, I can define an object however I want. I can find something. And so that's what you're going to see here with the assignment operator right here. There's a thing called the assignment operator, which is a little less than sign and then a dash. Now, the easiest way to get that in R, rather than typing 2 characters, the easiest way to get that in R is to use Alt dash, or I believe it's Option dash in Mac to get that. So Alt dash, and you'll get the assignment operator. So I can do anything I want. I could say, my word is, hello world. You can do something like that, and then you can see here it's stored here. Now I can use that, however I want. If I could say print my word, print hello world. So we can use that however we want. You're going to see that this is going to be much more powerful to do. We're going to create objects, and so objects will be anything. Objects will be anything from a number, a vector, like a list of numbers or a column of numbers. It could be a data frame, like an entire data set. It could be the results of a regression model. You'll see that in a normal sort of workflow, there'll be a lot of things over here. And that's one of the flexible parts of ours. We don't necessarily have to close a data set and open a new one or something like that. We can work with a lot of different data sets and objects at the same time, which is quite nice. So if you want to ever clear the contents of your global environment, you can just click on the little broom here, and now you're starting over. And so we can go over here and do that. All right. So another thing that I want to show you, another thing that makes R distinctive, in addition to objects, is functions. So in a program like Stata or SPSS or SAS, we have commands that do things, and in R, most of the things are functions. So I'm going to just clear this so we can get a nice fresh start. And so I'm going to create an object which is called my numbers, and I can make that if I want to put more than one thing, I can concatenate. That's what that little C means, for combine. I can do 1, 2, 3, 4, 5. Okay, so you can see now I've just created a little vector that says my numbers. See, it's a numeric vector, 1, 2, 3, 4, 5. And so one of the things we can do once we're using when we're using R is we can use functions on objects. So in this case, I'm going to say, what's the mean of my numbers? Take a second, think about what the mean of that is going to be, and you hit that, and it's like, okay, great. The mean is 3. You could say, what is the maximum value of my numbers? And the maximum value of my numbers is 5. You know, again, you could say, what is the minimum number of my numbers? Okay. You get the idea. Whoops. The minimum of my numbers is going to be 1. Okay, and as you see, you can see I can go through my previous commands here using the up arrow. So if you're used to, I used to be a Stata, I mean, I still use Stata for some things, but mostly I use R these days. And in Stata, as you probably know, if you're a Stata user, you can do page up or page down to get to previous things that you typed in the command window. And it's similar in R, it's just the up arrow. We can go back to things. So that's why, you know, I could just go up and modify those. So that's why that's there. So we're going to use function. We're going to apply functions to objects, and that's what you're going to see. So anytime we're going to do anything from just taking the mean of a number to doing a regression model, you're going to see the same basic structure. Where there's going to be some kind of function, and then in parentheses, we're going to execute that function on an object. Okay. One thing to remember is that R is case sensitive. So if I try to say, you know, what's the mean of, you know, my numbers, it's going to try and see, it's doing this tab completion here. It's like trying to help me not make a mistake. But if I did that, for example, if I did the mean of my numbers, it's going to say it doesn't know that it's there. It doesn't know that it's there because R is case sensitive. So that's why that doesn't work. So R is usually pretty smart about trying to help you do the right thing. It does use tab completion in RStudio. So if I start to type the name of an object, one really nice thing is that you don't have to worry as much about long file names or long object names. You don't have to worry as much about underscores and things, because if you just start typing, like watch, if I just start typing mean my numbers and I don't put the underscore in, it knows what I'm trying to do. And so then I can just hit tab and it will do tab completion. So that's really nice. That's, you don't need to know that, you know, that you can get by without doing that, but that's something to do. So, so what I would recommend here is now pausing the video and taking a second and doing something that's like what I did up here, creating a little list of numbers and just trying to take the mean of that list of numbers and make sure that you understand what's going on. So first, you know, create an object like this, and just don't forget to use the combine or concatenate operator here to put them together with the little commas. And then if you want to do sequential number, I can, you know, you can do this instead. If you want to just do a sequential number, you can do something like this. X is 1 to 10. And so you can see here now X is the numbers 1 to 10. You can do that as well. But the idea is I want you to just create a couple of little objects and then take the mean of them or do the min or the max or whatever you want to do just to get familiar with it. And then come back and we'll keep going. Okay, great. So now that you have the basic gist of an object, you know, you created some basic objects and you've done some basic functions, we're going to try to move on to something a little bit more comprehensive. And so what I'm going to start with here is, and I'll get rid of this as well. So we start with a clean slate. What I want to teach you how to do now is to create a project. There are a lot of advantages to working, you know, so far we've just been working. If you look up here in the top right, you're going to see that it says project none. You can work in RStudio and not be in the context of a project. In fact, I did that myself for, you know, the first maybe 6 months or so that I used RStudio. But I'm going to, you know, really encourage you to get used to using projects. The main reason for using projects is that it will take care of the relative path problem for you. So as you know, if you've ever worked on multiple computers or you've ever been collaborating with another person who has a sort of different file system from you, as you're sending files back and forth, or as you're using the same folder on different computers, if the path name is different and you're trying to, like, let's say, load a data set that on one computer is, you know, C users / BASI / whatever, and then on a different machine, it's not BASI, it's SPV or whatever, I mean, then you have to worry about fixing the path. Using projects will prevent that from happening because projects use what are called relative paths. So when we're in a project, it knows what the home directory is. And then it will automatically, you'll be able to just use subfolders and stuff. I'll show you an example of what I mean. So if you're about to take a Code Horizons course or a Statistical Horizons course, chances are you're going to download some stuff that the instructor is sending you. Certainly that'll be the case if you're taking one of my courses. And as you can see here, I have a thing called My Course. And this is the kind of thing you might download from my course in preparation to take my course. You can see here, maybe there's some data sets, there's some exercises, there's some, code for the slides or the slides themselves in here. and then a script file that you'll make at some point. So when you first get it, it wouldn't have this, but I just put that in there because I'm going to show you what that can do. So we have a folder, and I put this folder on the desktop, not because that's a good place to put anything for the long term, but because it's just visible and you can see it. And so the nice part about projects is it really doesn't matter where I put something initially, because when I'm done with this course and I want to put this somewhere, I can move this to anywhere in my file structure that I want, and it will work out just fine. I can put it anywhere in the file structure that I want, and it will still work because none of the paths will be broken. So let me just show you how to get started with the project. Okay, so we'll go back to RStudio here. Go back to RStudio. We're going to go up to the project here. And so we've opened the project pane. You can see there are several options here. I'm going to do new project. And it's going to think for a minute. And then it is going to give me the option of creating a new folder, as you'll see, using an existing folder, or creating a new project using version control like GitHub or something like that. So I'm just going to use an existing directory. And the reason I'm going to do that is because I've already downloaded a folder from Code Horizons or Statistical Horizons that says, okay, here's the content you're going to need for this course. So that's already going to be in a folder. And so I can use that, or maybe you just create a folder on your hard drive somewhere and just say, hey, come on, this is the name of the course. This is what I'm going to take. This is where I'm going to put all my stuff for that course. Whatever, that's up to you. But we're gonna do this with an existing directory. So I'm going to say existing directory, and then it's going to say, hey, where do you want to, what directory do you want to use? So it's asking for the project working directory. So I'm going to go here and I'm going to go up to desktop. I'm going to go to the desktop here. And I'm going to click on my course because that's the folder I want to use for this project. I'm going to click open. And then, here it is right here. I've changed that. And then I'm going to go here and click create project. Now you can click open in a new session or not. I don't really have anything else going on. It's probably for maximum sort of consistency. It's probably a good idea to check that box. But I'm going to go ahead and now click create project. You're going to see RStudio is going to restart. And now, what is different? The only thing that's going to be different now, nothing looks different right now, except for you see up here, it says my course. That's the project that I'm in, is my course. If I go here to files, you'll see that I'm actually inside the course folder. So anytime I open this project, I will be inside this folder. And so that means I can move this around, I can do whatever I want, and I will always, when I'm inside this project, it will always be in the proper home folder. So the easiest way to implement this is going to be to, let me just close out of RStudio entirely. The easiest way to implement this is going to be to find where your project is. And you'll note here that I've got a couple new things inside my folder. I've got mycourse.rproj, which is an R project folder. And I also have a little hidden folder called .rproj_user, and this is just information about the project, which I don't really need to see. That's why it's hidden. I just have seeing hidden files on by default. But I can click here, and you can see you can note here that I don't have RStudio open at all, but I can open RStudio from here, and it will. And I'll be in that project. So I could take that folder. I can move it anywhere I want. I can move it to the C drive. I could email it to a different person. I could do anything I wanted to do, send it to another person. And as long as they open it by clicking on that link, everything will work. The paths will work and everything. So projects are quite nice. Projects are quite nice. So what I'm going to do here is I'm in a project. I'm in my project, and I want to. So first of all, before we go on, take a second, pause the video, and create your own folder and project. Doesn't have to have anything in it. Just create a folder somewhere and then associate with a project, and then pause it and come back, and we'll continue. Okay. All right. So now that we have a project and it's associated with a folder, we can open an R script file, and we can start doing some things. So we can open and start doing some things. So there's a good reason to do things here in this file rather than to do them down here, because if I do them down here, they just they happen once and they disappear forever. it would be like doing things in the command window in Stata, for example, if you're used to that. There's just no, you could have a record of it. If I had the history tab up here, you could have a record of it, but it's not the most permanent way and not the most reproducible way to do your own work. So in general, you're going to want to do something in a .r file or potentially in a markdown file, which I'm not going to talk about today, but there are other ways to do this. But the simplest way to do it is with a .r file. So I've opened this. It's just a plain text document. It's just a plain text document. I could open it in Notepad or Notepad++ or Sublime Text or anything else. I could open it up and it's just a plain text file. And so I will I'll show you what I mean here. So I can do I kind of reproduce my workflow here. I can say print hello world. I can say 2 + 2. I can say x is 1 through 10. I can say take the mean of x. I can say take the get the minimum value of x. So you can see I've typed all this stuff out. Nothing's happened down here. Nothing's happened down here. So I can do a few things. First, I can save this file, which is probably what I want to do. I want to save this file. And it's going to say, hey, okay, where do you want to save it? But note that it knows that it wants to save it inside the project folder, which is really useful. So that's one of the advantages of projects is you're not going to save files in the wrong spot. You're not going to save them in the downloads folder or any sort of random place. You'll save them in the right spot. So here I'm going to just do, my first script or something, .r. And I'll put that here because we're using a .r file. So my first script, I'm going to go ahead and save that here. And so now, no, nothing's happened. None of this has been executed yet. I've just saved this file. You can see now it also exists in, in the files here. But in the environment, you can see there's nothing here. I haven't executed anything. I haven't done anything here yet. And so there are a few things I can do. The easiest thing to do is I can select a line of code. I can select a line of code and I can click run, or I can do Control Enter, or it's probably Command Enter on Mac. I'm not 100% sure, but if you hover over this, it should tell you. But I can hover over this, and I can either click Run or do Control Enter, and you'll see down here once I've done that, it executes the command. So I've done this here. I'll do this again here. Run. I don't have to just execute things one line at a time. For example, I could pick all of this. So let me just clear this. That's a Control L or probably Command L on Mac. It's not a really important command. It just, I get distracted very easily. So I like to clear the console. That doesn't do anything to the environment. It just cleans up the text on this side. I do that occasionally just because I get distracted very easily. So I like to have a clean slate and be looking at that sometimes. So so I can select all these lines right here like that and do Control Enter, and it will execute all my commands. And you can see here, X, which is the object I've created, is here. And I've got these here like that. Now, one of the interesting things I can do as well, which I didn't talk about before, is let's say I wanted to save the mean of X as a new object. So let's say I wanted to say, well, I want to do the mean of X is the this. So I want to save it, and I want to create a new object, which is the mean of X, which is the result of doing this function, of doing the mean of X. If I do that, you can see that this new thing has appeared here, a new object in my environment, which is this. And so I can assign, I can essentially, this is the most basic thing you're going to do in R, is you're going to name an object, and then you're going to say, okay, this object is defined as this, the result of this function. So that's what we're, that's what we're going to do here. So I definitely want to do this work here instead of this. Now, everything that I put here, R is going to interpret as a command. I can save this if I want, just by clicking that or doing Control S or Command S. I assume it's Command S in Mac. So here we go. I can, what else can I do? One other thing that I want to show you. So we can select a few lines and run them. We can select all the lines and run them. We can select one line and run it. The other thing we can do here is we can add comments. So I can say, I'm going to try a few basic commands. And you can see that the editor here, the editor has put this in gray and italics. And that's because anything that comes after a hash mark here like this in an R script is what's called a comment. That means that R, the engine of this, is just going to ignore that. And so if I select all this and run it, it doesn't do anything. It doesn't produce any output. You can see here it saw it, but then it just continues to the next line because it didn't do anything. So that's a good way to just to put notes to yourself, explain what you're going to do. And so you can be very, verbose here. It's like, I'm going to use R as a calculator, or create a vector of numbers from 1 to 10. Take the mean of that vector, like this. Save the mean of that vector as a new object. And in fact, you're going to see, and you probably know this if you're used to other software programs, because this is just part of data analysis, that you're going to not only going to collaborate with other people, but your most important collaborator is usually your future self. And sometimes your future self can't remember what your past self intended to do or was doing. And so in this case, it's really good to be kind of verbose and give yourself comments about what you're going to do. Okay, so this is the basic stuff in R. So I'd encourage you to take a moment to pause the video, take a moment, create your R script, try out some basic commands, try some comments, and just make sure you can get everything to work. So go ahead and take a moment and do that, then pause the video and come back and we'll keep going. Okay. All right, so one thing you probably know about R is that it is extensible, meaning it has a lot of user-written packages and other things that we can use to make R more powerful. And so, so far, in everything we've done so far, we're just using base R. So we haven't had to load any packages, or install any packages, or do anything. All the functionality of the basic stuff that we've been doing so far is just using base R. But there's some things we might want to do with packages. And so one of the most common packages that a lot of instructors use, not everyone, but I certainly use it, and several people do, is the tidyverse package, which is a collection of packages that are from RStudio that help you do some data management tasks, and I think more, in a more transparent way than some of the base R functions. And so, in any case, I'm just going to show you how to do that. So there are going to be 2 steps to using a package. There's one we need to do once, and then there's another step we need to do every time we start a new session. So if you go here to the Packages tab, it's going to show you a list of all the packages I've installed, and I use R a lot, so I have a lot of packages installed. But if we want to install a new package here, where do you want to install it from? Do you want to install it from a local file or from a repository? In almost every case, you personally will want to install it from a repository. And so then you want to type the name of the package you want to install. So here I'm going to put tidyverse, and when you start typing it, it will, it's going to narrow it down. So that's nice. So I'm just going to click tidyverse. I already have it installed, but I'm just going to reinstall it just so you can see how it works. And then you can click install. This, and yeah, there we go. It installed. You can do it that way. If you want to do it, so you can see here, it actually typed out the code. So the packages way, the way I just did it using the packages interface is one way to do it. And that may be simple for most people, especially because it will autocomplete for you. If you let's say you didn't know that it was called, tidy, verse with a lowercase t, you might put capital T, and it's going to try to autocomplete that for you in the right way. You can also just type install packages, install.packages, and then put the name of the package you want in quotes, and that will also work. But this package interface is useful. And so now that I have it installed, you can see if I scroll all the way down here, I know I have a lot of these installed, but if you scroll sort of all the way down, you'll see that I have tidyverse installed, but you notice there's no check mark next to it. And that means the package isn't loaded. It isn't loaded. And so this is something I encourage you not to do, like very strongly encourage you not to do. I could click this, I think, and it would load the package, but we really don't want to do that because it's not reproducible. What you want to do is at the top of your do file, or that's a state of talk, the top of your R script, you want to use what's called the library function, and you want to load the package. So I'm going to do this, load tidyverse. Library, so you can say library tidyverse. And then what that's going to do is, let me just start a new R session so we can start from scratch. where is it? Session restart R. I'm just going to restart R completely. So everything's empty. We're starting from scratch. Now, when I go here, so you can see restarting R session, I'll just use Control L to clear the console again, just for my own. That's aesthetic. I just want to be clear. That's not doing anything except aesthetically getting rid of text that I don't want to see anymore. Okay. So I can do this and run all this stuff here. So I'm going to select it all. I'm going to run it. And the first thing that happens is it's going to load the tidyverse. So it did load the tidyverse. You'll probably see a bunch of, if you try this yourself, you'll probably see a lot of text afterwards that shows you exactly what packages are being loaded. I have some of that suppressed. I'm not sure because I use tidyverse so much, I don't want to necessarily see all that output here, but that's it. So now I have tidyverse loaded and I can use the tidyverse functions. And so what a package is, I should be clear, is a set of new functions that you can use to do things that base R can't do. I'll show you a couple of those as we go forward. The most common ones, the most common parts of the tidyverse that are the dplyr functions, which are for data management, the broom functions, which are for summarizing model fit, model statistics, getting coefficients, things like that, and ggplot for plotting, which if you've heard of anything in R, that might be one of the things that you've heard of. So ggplot is also part of the tidyverse. And so if we use the tidyverse, well, we're also using ggplot. Okay, so all that stuff is here. So we can load a package. So general practice would be that if you're going to use an outside package for something, that you would put it at the top of your script file, so that your code is ready to use the functions from a new package that you are bringing up here. Okay, so that's what we want to do. So I'll show you what a tidyverse, what the tidyverse stuff looks like in a second. But first, I want to introduce something that might be a little bit unusual, but I think is a good thing to introduce to people. It's now part of base R. It used to be part of a separate package, but it's been so popular that now it's integrated into base R, which is a thing called the pipe. And so I do want to take a moment to explain to you how to use the pipe and how sort of simple it is. And so let me just do pipe demo. Okay, so I showed you already you can do something like this. We can go ahead and create a little vector of X. I already did that. I can take the mean of X, etc. That's fine. One of the things, so the most common way to execute a function is to take that function name and then inside the parentheses after that function, give it an object that you want to execute that function on. Now, another way to do this is using the pipe. Now, when I do it this way, it's going to seem like this is kind of overkill. But when we get to some more complicated things, hopefully you'll see how this might be valuable. And so you'll see this in some of my code if you're taking a course from me. You'll see it in some other people's code if you're taking a course from them as well. And so I do want to introduce this to you so it's not totally unfamiliar when you get there. So we're going to look at the pipe. And so how the pipe works is we take an object like this, like X, which is already defined. You can see down here, X is defined as the integers from 1 to 10. We can take X and we're going to put a pipe in here. Now I will, there's a cheat sheet I'm going to distribute with this course that will give you some of these shortcuts, but I want to show you that it's, in Windows, it is Control-Shift-M adds a pipe. I believe it's Command-Shift-M in Mac. So, take a minute and try that out. Try getting this. All it is though is a bar and a greater than sign, like that vertical bar, which is usually below the backspace button on most on QWERTY keyboards, and then a greater than sign sort of right next to each other. But you can do the shortcut for that with Control-Shift-M. And so what the pipe does is it says, okay, take this object and then use it in this function. So I can do, instead of typing mean X, I can take X and then pipe it to the mean. So the way you would say this out loud is take X, then take the mean of it. And so normally we would pronounce this as then. And so if I do this, whoops, I'll do Control Enter. Whoops, I just hit the wrong thing here. But I can do Control Enter, and as you'll see, it gives me the right answer. So it takes the mean X and pipes it to the mean. You get a mean of 5.5. So that's how it works. So mean X and take X and take X and then take the mean of it is going to be, those are equivalent. And this is part of base R now. I don't need to load any packages to get this to work. Now, if you're using an older version of R, you might see a pipe that looks like, let me put it, you might see a pipe that looks like this, like that. And so that's like that's the pipe that came from the Magrider package. And so you will see that in some code. You'll definitely see that in some people's code, because the native pipe, which looks like this, is relatively new to R as of R 4.1. So it's pretty new. Whereas this is the sort of older pipe. And so you can get R to put the pipe that you want. If we go up again here to tools, global options, if we go to code, the code panel, you can see here there's a lot of different options, but the one that's relevant here is use native pipe operator. And so if that's checked, then when you do Control-Shift-M, you're going to get this pipe. If you use Control-Shift-M and that's unchecked, you're going to get a pipe that looks like that. But they both do the same thing. There are very, very, very few situations in which there's a difference, between the two. And so I moved toward using the native pipe. It's implemented in C++, so it's faster than the native pipe. I mean, than the Magrider pipe, and it also doesn't require you to load any additional packages. So I've moved toward the native pipe. And if you're just getting started in using R, there's no reason for you to not use that. But I just want you to recognize that if you see this in somebody's code, it means the same thing as this, and we can just take that object and do things to it. So let me show you a little bit more, something that's a little bit more complicated. So I want to use some data here. So in order to demonstrate to you how some of these things fit together, I want to bring in some data and help you see some basic things that we can do with it. And so there are a couple different ways we can get data in R. Number one, R comes with some basic data sets. So it's going to come with, just like, Stata does. Stata has the auto.dta data set. And so very similarly to that, R has the basic data set that it comes with called mtcars, which is a data set of cars. And so because that data set comes with R, you don't have to load it from a separate place or anything. You can just use the data command like this. We can just do data. I'll make a comment here. Bring in mtcars data. And so I'm going to say data, and I'm just going to type mtcars. And so because this comes with R, I'll show you how to load a packet. I'll show you how to load a data set from the disk in a minute. But I want you just to see, we can demonstrate some basic stuff with this. And because this comes with R natively, we can just do data mtcars. I can run that command with Control Enter, which is what I did. And now you can see that mtcars is here. Now you're going to see here it says promise. And that's because it's waiting to see if I'm actually going to do something with it. So if I don't do anything with it, it's not going to waste time bringing it into memory. But if I start to do something that seems like it's going to use it, you'll see this promise turn into the actual thing itself. So I'm going to do summary MT. See how it saw I was going to do something. So it's like, oh, okay, we'll get it ready for you. So I'm going to do summary mtcars. Before I do the summary, I just want to show you what this looks like. It looks like data right now. It looks like data. And when we have something that looks like a data frame, you're going to see you can actually click on this in RStudio, and it will open it in a spreadsheet-like viewer. And so we can see what the data set looks like. It's a rectangular data set of a certain, I can't remember exactly how many, but a certain number of cars. And then it has a bunch of variables that are associated with it. So here are the names of the cars. Here's miles per gallon, the cylinders, displacement, horsepower. I can't remember what all these things mean. Weight. So you can see how all these things are here. So this is just a normal rectangular data set of the kind of data that anybody would have. So I can click on it over here and open it up, and just to get familiar with it and to see, we're not going to do anything with this. It's not like Excel. We're not going to do anything directly, with this. We could cut and paste or something if we wanted, but there's really not much reason to do that. So I just wanted to show what mtcars looks like. So mtcars is now, you'll note it's in the thing. So I can do things to it. It's an object now. So I can apply a function to it. One function that I can apply to it would be the summary function. So I'm going to say summary get descriptive statistics for mtcars. And so I can select this and hit Control Enter again. And you'll see down here in the console, it's giving me some summary statistics for all the variables here. So I got miles per gallon, minimum, maximum, median, mean, first quartile, third quartile. And you can see it's doing this for all the variables. So if you want just some basic summary statistics, that's one way to do it. Yeah, so anyway, that's the idea here. You can see this now. So objects in R are, for want of a better word, I don't know what the technical term is for this, but they're hierarchical. And so that means objects can have sort of parts to them. And so if we look at what the structure is, so str, you don't need to know this, I'm just going to use this to show you, but you can get pretty far without using this command. I'm just going to show you str empty cars. It will show you the structure of that data frame. It'll show you what the structure is. And you'll see it's got 32 observations of 11 variables. And it's going to show you this like $MPG, $cylinder, disk, all that stuff. And what that really means here is that these are all sort of sub objects, if you like, inside the object empty cars. And so if I want to get like the mean of miles per gallon, we can't do what we can't do the kind of thing we would want to do in Stata. So let me just show you an example. So let's say get the mean of miles per gallon. If we can't do what we would do in Stata. If we were in Stata, we might just give it the name of a variable, but we can't give it the name of a variable because R doesn't have just one data set in memory. So it's here, but I can have lots of data sets in memory. So if I want the mean of a variable, I can't just ask for the mean of that variable. I have to say something like mean empty cars MPG. See what I mean? Like that. So if I just want the mean, I have to ask for the specific variable and the specific data set because there might be more than one data set in memory. So I can't just say like mean MPG because R won't understand what data set I'm referring to. So anyway, I'm doing this and I can, select that and we'll say, hey, here's the mean. The mean is 20.09. So I can do that. With anything that I want to do. Okay, so this is the mean of empty cars. Now I can try to do this with the pipe too. Same idea. I can do empty cars, MPG. So this is an object, which is, let's take a look at it. What is this object? This object is just a list of 32 miles per gallon from cars, or it's a vector technically, but you can see what it is. And so when I take them, so then I can take that object and I can pipe it to the mean function and I will get the same answer. You can see. So this is just, and so some people, including me, find something like this easier to read than something like this. Especially when you're going to see when we start nesting things together, it's going to be easier, I think, to see in this using this sort of pipe notation. But some instructors will use this and some will just use parentheses. So, FYI, I just want to show you both ways. But this is the idea that this is the variable that's inside that data frame. So that's how we'll index it. Okay. So that's one way to do this. Okay, now I showed you how to get a data frame that is installed in R, that comes with R. But what if you have some data that is just in that is just on your hard drive? And so if I look here, if I go back to files, I can see inside data, I have a little data set. I have a BW dataset.r data. That's the native format for R data, is the .r data format. And so I can bring this in. Now, the easiest way to bring this in is going to be, I'll show you how to do this. I want to say load data from disk. Okay, now I want you to think for a second. The home folder, the home working folder for this project is right here. Okay. But the data set that I want is inside a subfolder called data. This is where projects are really useful because what I can do is I can just type load, and then I'm going to put the name of what I want in quotes. And so I can't just put, whatever I have here, BW data. I can't remember what it's called. I can't just put, BW data set. What is it called? Okay, BW. Okay, I get it. BW data set .r data. And so if I try this, it's not going to work. And hopefully you can see why. It's because it is in this folder. It's going to look for it in this folder. It's going to say, hey, look, cannot open that, no such file or directory. Doesn't know where that is. But because I'm inside a project, I can actually just do this. I can just type this. And so what it's saying is, hey, go into the subfolder data and get this out. And so this is what's called a relative path. And so because I'm in a project, no matter where I move this project folder, anywhere on my computer or somebody else's computer, this will always work because it's a relative path. So I'm just going to get rid of this so you can see it a little more easily. Here we go. And there it is. Now you can see if we go back to the, it doesn't look like anything happened. But if we go back to the environment, you're going to see there's a data frame here, which is called D, very creatively named D for data, that's what I called it. And so we have a new object here, which is D, which is a data frame. This is a birth weight data set that I use for some matching and weighting courses. It's about some mothers who let's take a look at it. So we can do the same thing when you do with empty cars. We could click on it and just take a look at it. Now this is a much larger data set, so that might take a second for it to load up here, but you can see what it looks like. It just looks like a normal rectangular data frame, obviously a lot longer, 4,642 cases rather than just 32. So I'll show you a couple other ways we can look at things that don't require looking at the whole data set at the same time. Take a look at the data. Okay, so I want to here do, there's a couple different ways we can do this. There's a base R1, which is called head, and we can do head D, because the name of the data frame is D. That's what it's called. That's what R knows it as. So this is the file name. That's fine and dandy, but that's not that's not how R thinks of it. R, because I saved it with this name, that's what it thinks of it as. So I can just take a look at it here, and this will show you, the first. It'll show you the first few rows, and that's how that works here. And then the first few rows. We could also do, there's a tidyverse version of head that works a little bit differently, which is called glimpse. You can do glimpse here, and glimpse it's oriented the other way. And so the variable names are here, and then it will show you as many as it can fit going left to right. And so you can see how that works there. So head or glimpse, those are sort of equivalent. They don't do exactly the same thing, but they're functionally equivalent in the sense they're attempting to do the same thing, which is get you a sense of what the data set looks like. Now, the reason I like glimpse better is because you'll see that when we use head here, if the data set has a lot of variables, it's going to say, hey, here are some variables you can't see. Whereas here, it's going to just, because it's using the vertical space better, it's going to be able to show you, all the variables. So I prefer glimpse. It does require tidyverse. If we try to do this without loading the tidyverse first, it doesn't know the glimpse function. Remember, glimpse is a function, and packages are collections of functions. And so we got the glimpse function from Broom, I believe it is. So anyway, that's what we got here. Okay, probably not actually. Let me see. Glimpse comes from dplyr. Okay, so dplyr. There it is. Okay. Oops. Comes from dplyr. Okay. All right. Anyway, so we can take a look at that data set. So those are two different ways to get data. If a package has data that it already comes with, that's great. We can use it we can get it using the data command, and that'll work. If it is on disk, we can use load to get it. And you can of course use other things. I'm not going to show you how to load packages from other kinds of software, but you can use. If you are going to bring in data from other kinds of software, I want to just point you toward the Haven package. And I'm not going to demonstrate it because this is very basic. I'm just trying to get you the very basics. But the Haven package that comes with tidyverse is a great package for loading data sets from Stata, SPSS, SAS, etc. Okay. All right. A couple more things. All right. So let me show you a couple things with. Let's get a little room here. Let's show you a couple things with dplyr data manipulation, data wrangling type stuff. So you can see here that we have this data frame D, and it's got a lot of variables. We have 23 different variables, 4,642 people. These are all women who had babies. And so we get some information on the babies and some information on the women. And so let's say, for example, I didn't need all this. I just wanted to know the birth weights and whether the mother smoked or not. So I didn't want to keep all these variables. I wanted to get a smaller version of the data set that just has the two columns. Whether the mother, like how much her baby weighed at birth, and how much, whether she smoked or not. So the way I can do this is say select a set of variables or columns. I can take this, I can create it. So remember, I'm going to create a new object. So that's what I want to do. In R, generally, when I'm doing something, I want to create a new object. So I want to create a small data. So I can call this whatever I want. I can call it whatever I want to do. Small data. And I can say, all right, so how am I going to do this? I'm going to take my data set D. I'm going to use a pipe. And then I'm going to say, hey, select the two variables I want, B weight and MB smoke, like this. And then it will create a new data set for me. And you can see now it's 4,642 observations of two variables. So, I can do that. I can also, let's say instead, and I also want to keep, I also want to keep women, women who are, under the age of 40, so I might use filter for that. Filter a, so its mother's age is less than 40. So I can do something like this too. So that's one of the other advantages of the pipes. I can take an object like D and I can send it down through the pipe. So take D. So think about what I'm doing here. I want to create a new thing called small data. The way I'm going to create that is I'm going to take this data set D. I'm going to select just these two columns. This is actually not going to work because I don't have age in there, but I'm going to do this first. I'm going to do it in a different order. I'm going to filter those. I'm going to keep the mothers who are less age 40 or who are less than age 40. So I think it's in this data set like 16 to 39. So I'm going to filter them, and then I'm going to keep just these two variables like that. And so that's what it's going to do. It says take D, then filter the mothers who are, keep only the mothers who are below age 40, and only keep the variables that are these two variables. So if I do that, you're going to see now small data is 4,585 observations of two variables. So anyway, you can see how that works and why the pipe is useful. Now there's a lot more to, this is just an example of data wrangling. If this is confusing to you, like what's filter, what's select, I'm going to point you to some resources at the end that will help you get a handle on those. But I just want to give you a sense of how these things work. One final thing that I want to show you is how regression outputs, look. Not all your courses will involve a regression, of course. Well, first of all, pause the video for a second and go ahead and give that a try. Just load either loading MTCars would be a good idea, and then use Glimpse or Head, things like that. Try that for a second, and then come back. Pause the video, try that for a second, and then come back, and I'll show you one final thing. Okay. All right. So the last thing I want to show you is just a basic, I guess a couple things: a basic plot, a basic regression. So let's work with MTCars because it's a small data set. It's relatively easy to visualize. So I wanted to show you a couple simple plots with MTCars. So any plot that I'm going to make in sort of real life, like for publication or anything like that, is going to use ggplot. But that's a topic that's more complicated than what we get done in just a few minutes. So I just want to show you a couple of base R commands to get like kind of ugly but like serviceable plots that can just help you see what's going on. I wouldn't recommend these for publication, but they're useful just for kind of you to see what's going on. So if I do, so let's say I want to see the distribution of miles per gallon in the MTCars data set. So there's a function for that I'm going to apply to an object, and that function is going to be hist. And so I'm going to take hist and I'm going to apply that to MTCars, and I'm going to apply it to the miles per gallon variable in that. So I'm going to do that, and you can see, here it goes. So that's what the plot, finally I'm using the plot pane here, but you can see here's what the distribution looks like of MTCars. So it's going to automatically draw this histogram. It's going to show me kind of the distribution. The range looks like it goes from about 10 to 35. The modal is somewhere in between, 15 and 20. You can kind of see how this works. And that's just the hist command. So I can do hist for that. I could do hist, MTCars, horsepower. Do the same sort of thing. There's the horsepower. I could also I could do it with a different data set. Let's say I wanted to see what the the distribution of birth weight was in that other data set that I loaded in. I can do that too. It's in grams. So the idea here is that I can do any of these things, and because I have multiple data sets in memory, which I always will in R, or I always have the option to do in R, I'm going to I have to tell it what data frame I want to pull the variable out of that I want to do something to. So that's just a simple histogram. And you can use that. This is not publication quality, but you can use it just to visualize something for yourself. And I do that all the time. Another plot would just be like a basic scatter plot. So a really basic scatter plot. And so for that, we're just gonna use the plot command, and we're just gonna give it an X variable. You can see here, it's kind of trying to help me. It's giving me a little info. It says, give me the X variable, and then give me the Y variable. And again, I can't just give it the variable names because it doesn't know what data set it's referring to. So I could say, well, I'm gonna do MT cars, horsepower, it will be X, and MT cars, MPG will be Y. And I could plot that, and here's a basic scatter plot that will just show you the relationship. Now, ggplot can make much more beautiful graphs. It can do, that's just way beyond the scope of what I want to do, which is just kind of get your feet wet in R. But just take a moment, pause the video, take a moment, and try to make a simple histogram and a simple scatter plot using MT cars. And when you've done that, come back and restart the video. Okay, last thing I promise that I want to show you is just what regression output looks like. And the reason I want to show you that is because, if you're used to Stata or SPSS or something like that, you're used to the result of a regression being text, like a report of text. Whereas in R, you can get text, but the native production, the native thing that a regression function is going to do is produce an object, another object, which contains the results from that function. So let me show you what I mean here. So let's say we want to do a simple regression, and I want to do the regression that is represented here. I want to regress miles per gallon on horsepower and see like how horsepower affects miles per gallon. And so let's just do simple regression. And so base R has a command called LM for linear model, and that's what we're going to use for that. And so let's take a look at what this does. If I just type LM, and then I'm going to give it a formula, and the formula is going to be, so I can do this two different ways. I'll show you two different ways that are equivalent. I'm going to do MT cars MPG is a function of MT cars HP. I can do this like that, and it will give me the result. Oh, here's the intercept, and here's the slope. Okay, but it's not giving me any standard errors. It's not giving me anything. And that's just because it's very taciturn. This way of doing it is very taciturn because this is just the output that falls out and execute the command. So this is generally not what we're going to want to do. So there are a couple of things I'm going to recommend you do differently. One is just to make it less ugly. I want to do this. I want to do LM. I'm going to do MPG as a function of HP, and then you can just tell it what data set to look in. So if I do that, then that will work. This will work. So it'll give me the same thing that I got before. Now it's still ugly. It's a little less ugly, but it's still ugly because I haven't used, I haven't asked it to actually tell me things. I've just said do it. And this is just kind of the merest byproduct of that thing. And so if I'm ever actually running a regression model, I want to save the result of that as an object, which is going to be unfamiliar to many people, but that's where I can actually do stuff. And so as you can see here, I'm doing this. Here's the basic stuff. As you'll notice, probably, this will work too. It's not like Stata in that regard. It will try and sort of intelligently figure out where you want the command to end. So it knows this is not a complete command. So if I try to execute this line, it'll just be like, it'll be waiting for the next part. So you can use indentation and things to make your stuff a little bit easier to read. And that's what I'm doing here, putting the formula on one line and the data argument on the next line. So let's just say I want to do, I want to say this is an object. That's what I'm telling you that you want to do. You want to do my regression, or my reg is going to be a function. It's going to be a new object that I'm creating, and it's going to be whatever results from this function. So my reg is going to be whatever comes out from this function. Okay, and so I'm going to. So I got that there. And so now I'm gonna run this, and you're gonna notice here. Let me just get rid of everything just so you can see exactly what happens. I'm gonna take this, I'm gonna run it, and you're gonna note it says, hey, look, I did it. But it doesn't produce any output. But if you look over here, you'll see there's a new thing that came into being, which is an object called myReg. Now the simplest way to do this is to do summary myReg like that, and it will give you a summary of the regression. It will show you, oh, here are some, residuals, the normalized residuals. I think these are just residuals, actually. It will give you the coefficients, standard errors, t-values, p-values, it'll tell you, it'll tell you a bunch of different stuff. So that's the summary function. So many objects, not all objects, but many objects have a summary function that we can use. You'll notice up here when I use summary on a data set, it gave me the descriptive statistics for that data set. So many objects have, and many types of objects have specific summary methods that will produce useful output. So summary will do this. There are a lot of alternatives to summary though. For example, in my courses, you'll see me use tidy. And that's part of the Broom package. I'm gonna just load that real quick. I'm gonna load the Broom library, and then I'll do that. And you'll see, here's what it looks like here. And so instead of outputting it just as text, one of the nice things about tidy is it outputs it as another data set. So you can see here, like the result of tidy myreg is actually a little data set, which has rows for two parameters, and then the different variables are the estimate, the standard error, the statistics p-value, et cetera. We can also do, Broom also has a thing called glance, which will give you some other summary information about it. So the R squared, the adjusted R squared, the standard error of the estimate, the overall F statistic, et cetera. So, I mean, there's a lot of stuff you can do here, but the main point I want to get across is that we can only do this if we think about the output of a regression model as being an object that we're then going to do other stuff to. So that's the distinction. So we got functions, we got objects. There's a lot more to R, obviously, but I hope this gives you a basic introduction to what you might expect when you're using R. And it helps you be a little bit more comfortable into jumping into any of our courses at Code Horizons or Statistical Horizons that use R. So thanks for your time. Good luck. And I look forward to seeing you in class.